Okay, next one. So the last one we looked at was complement, and now we are going to look at compose. And actually, I mean, we've talked about compose. We've talked about compose and we've talked about pipe. So there is left to right composition and there is right to left composition. Compose is right to left composition and pipe is left to right composition. As you can see here, I mean, if we read the definition of compose, it says that the documentation says that compose performs right to left function composition. The rightmost function may have any arity, the remaining functions must be unary. So probably you already know this, and if you know this, you can probably skip this video. But otherwise, let's dig into this just to make sure that we've actually got it, and let's actually read the type definition here as well, so to make sure that we understand that. But let's jump back into Vim, and yeah, we've required Ramda. So let's see. If we compose, then we need to have two functions. So we need to have two functions that do two different things. So let's say that we have the function f, which when given some string, essentially just says string to upper, right? Is that the name of the function, or is it maybe to uppercase? Let's jump into Node. Like if I have the string foo, I can't say to upper, no? I can say to uppercase. Yeah, to uppercase. Okay, sorry about that. So yeah, so we have two uppercase. And of course, I mean, clearly there are Ramda functions for doing the things that I'm about to do, but I'm just doing something very simple in order to show what happens, or so that we can focus on the idea of function composition and don't get confused about different parts of Ramda. And actually, let me just say x here, so instead of a string. So f is a function. So f is a function that takes an x and uppercase is that x. Then let's find let's define another function g that takes an x and let's say adds an exclamation point to that g. Or why did I say g here? So to x. So f is a function that takes an x and uppercases it. G is a function that when given an x adds an exclamation point to that x. Exclamation mark, exclamation point. I don't know, sorry about that. So let's just look at these. I mean, if we pass foo to f, and or actually let me stop saying foo. Let's say hello, and if we pass hello to g, let's see what happens. So we run this, and you can see in the first case we get hello uppercase, and in the second case we maintain the lowercasing, but we add this exclamation point. So the thing is that we can then define a composed function. Let's say, I don't know what kind of the conventional letter to use for this is, but let's say h, right? So if h is the composition of f and g, so f-o-g. So this is hypothetical syntax. This doesn't make any sense in neither JavaScript nor in Ramda. But we tend to write this dot, this sort of period, when we talk about functional programming, when we talk about composition. So the composition between f and g. So h is the composition of f and g. And what that means is essentially it means f after g. So that means we first run g and then we run f. So informally, right? Now let's actually add this as a comment, right? So it's clear that it's informal. So fog is equivalent, or sorry, I should say fog as a function applied to x is the same thing as f applied to g applied to x, right? So applying the function g to the application, applying the function f to the application of the function g on x. So we first apply g to x and then we apply f to the result. And so the reason I talked about this sort of left to right or right to left is that compose is right to left and pipe is left to right. So if we do the same thing for pipe, like actually let's change the syntax. Instead of saying O, let's use this symbol. So 3 less than signs in order to say right to left composition. So moving to the left, and because then we can use a similar syntax. We use this syntax in order to talk about left to right composition. So left to right composition would, however, be g applied to f applied to x if we compose f and g, or if we pipe f and g. So if you think about it, I mean, left to right composition is very much like Unix pipes, and it's very natural to us as programmers. We say followed by, right? So if compose is after, then pipe or left to right composition is after, followed by. So we read this as f after g in the composition case, and if we read the pipe case, we would say f followed by g, right? So first do f, then do g. And in the compose case, we say do f, but only after you've first done G, right? So that's pipe and compose. And actually, I'm realizing we should use a better example than this, because maybe what we created now is sort of associative. But let's do that in a moment. First, let's just emphasize that here I use this sort of infix notation. So if we would express this using the Ramda compose operator, what we would do is we would say compose F and G, and then I delete up to here, right? So this line is the same thing as this line, sort of. And of course I would have to say R.compose. And this is actually closing in on valid syntax. I mean, now we're saying equals here, but then probably we would have to say equals because the left-hand side is equal to the right-hand side. Of course, I'm realizing now that I have this extra parenthesis here in the beginning that doesn't really belong anywhere. But anyways, let's remove this stuff, right? So let's go back to this H. We said we have an H function, which is the composition between F and G. So F after G. So that would mean R.compose F and then G, okay? And that means, well, we can call F normally, we can call G normally, but we can now also call H normally. So if I run that, you can see we do both of these things. We both do the uppercasing and we add this exclamation mark or exclamation point. So now we get now we get uppercased hello with the exclamation mark added. And the reason I said maybe it's associative is kind of that, I mean, it probably doesn't matter which order we do these. I mean, if we do G and F, yeah, we get like the same things. That doesn't really, that's not very interesting. So we should change. So maybe let's say that F is adding a question mark. Sorry, this is pretty silly. And G adds the exclamation mark. So if we run this now and we compose F and G, you can see we first get the, sorry, I keep pressing the wrong button. Then we first get the exclamation mark and then we get the question mark. And if I remove this single invocation of F and G, right, so we only have this as an output. And actually let's add here so we know which one we are talking about. So here it's, what are we looking at here? H on hello. Yeah, actually, let's do it this way. If we say R.compose F and G, yeah, maybe this would be a bit too tight for it to make sense. And then this is R.compose F and G, and we invoke it immediately with hello. Yeah, so hopefully that doesn't look too ugly. So instead of defining the function H, I'm doing the composition here, right? I'm sort of inlining the composition. I'm saying there exists a function that is the composition of F and G. Use R.compose to compose F and G, which will yield me a function here, right? If I add this parenthesis, it's super clear. Here I have a function, and then immediately I invoke that function by passing hello, or we apply that function to the string hello. And then we can see that, okay, so if I do R.compose of F and G, I get hello, exclamation point, question mark. Okay, but if I do it the other way around, if I say, okay, compose G and F, and then of course we need to change here in the actual invocation and not just a string, G after F rather than F after G, then you can see we of course get the other, or in the other order, we first get exclamation, or we first get question mark, and then we get exclamation mark. And this is why we can use pipe as well. So now we talked about R.compose only, right? We talked about R.compose, but we also have R.pipe. And so compose is right to left composition, but pipe is left to right composition, which is again more like Unix pipes and kind of more natural to us as programmers. So oftentimes I tend to actually use pipe rather than compose. But if I'm composing two things only, sometimes I tend to actually use compose because I think it sort of reads better. But yeah, I mean readability, right? Choose whichever one is more suitable for your scenario. So let's look at pipe. I mean, what's the easiest way to show this? Well, let's just do both of these things again, right? So we do the same thing, F and G in this order. Yeah, actually, let me put it like this. So these two functions have F as the first argument and G as the second argument, and these two functions have G as the first argument and F as the second argument. But then we want to change compose to pipe. So pipe here and pipe here, right? So in these two functions, we have f first and then g in terms of the arguments. F is the first argument, g is the second argument. And in the first of these two functions, we use compose, and in the second one, we use pipe. And in these two other functions, the first argument is g and the second argument is f. And in the first function, we use compose, and in the second function, we use pipe, right? Let's look at this. So actually, let me try to line this up. So pipe, of course, needs a bit more spacing. Let me go here, right? Add some more spaces, that should line up. Same thing here. Okay, let's look at that. Okay, lines up. So now you can see, if we look at this, the two middle ones are the same and the two outer ones are the same. So maybe we should organize them according to that instead, actually. So let's bring this one up here and let's run it. So compose of f and g yields the same result as pipe of g and f. Similarly, if we look at these two other ones, pipe of f and g returns the same result as if we did compose of g and f, right? Because they do it in the other order. Like, it's nothing strange, right? Compose just says, do f after g. So R.compose says, construct a new function, and this new function, whenever you pass it some argument, it will first do g, and then it will do f. So it will do f after g. But pipe is sort of the same thing. It says, okay, R.pipe says construct a new function such that when it's given some variable or given some input, it will first run that input through g and then it will run it through f. So if compose is after and pipe is followed by, then clearly these two are of course the same thing, right? Because compose, we're saying f after g, which is of course the same thing as g followed by f. Like, it's the same thing. And similarly here, if here we say, well, pipe, so we say followed by, so we say f followed by g, which of course is the same thing as saying compose g and f, because compose is after, so we're saying g after f. So do g after you've done f, which is the same thing as saying pipe fg, because then we're saying do first f and then do g. So f followed by g. Okay, so hopefully that makes sense, right? Because then you can see that we can sort of pipe these functions. And of course, the super powerful part here is that you can just keep piping. You just keep on stacking, you keep stacking on functions, right? So let's do something a bit more useful, right? Like let's say we have an incrementer function which adds 1, and then we have a double function that multiplies with 2. Then we can sort of, let's say we define a function f, which is the composition, or let's say the piping of incrementing by 1 and then doubling, right? So if we then console log f of 10, what do we get, right? We should first increment by 1, then we would double, and then we would double again. So we would say, we start with 10, we increment by 1, we take all of that stuff, right? The whole thing, and we multiply by 2. Then we take the whole thing and we multiply by 2. So we should get 44, right? And notice my usage of the parenthesis. I mean, the second parenthesis was just to be explicit, but the first one actually matters because arithmetic, right? Like, this is a different thing from this. And that's important because we are passing through the functions, right? Like when we've computed 10 plus 1, in some sense that's replaced by 11. Like, at that point in the execution, we don't know that we've ever had 10 plus 1. Like, there is no way of knowing backwards unless we sort of pass that through the functions. And so unless our functions sort of return some kind of history that other functions can use. But yeah, so we should expect to get 44. So let's see if that works. Oh, actually, molt is not a function. Sorry. So the Ramda function is not called molt, it's called multiply. I keep making this mistake all the time. So if we run that, we get 44, right? And this is how we can. This is how it becomes extremely reusable. So a lot of times we actually define functions in terms of them being a pipeline of other functions or a composition of other functions. And then you can get into weird stuff like composing over composition and stuff like this. But essentially, if you've looked into point free, for example, right? If you think about it, f is actually inc and double and f are all point free, right? Because we're saying inc is a function, but like, where's the argument? Where's this x, right? It's point free because we're just saying it's the same thing as adding 1. And then add1 is a curried function, which when we do this, we partially apply with 1. So it's a function that expects a second argument, right? It expects an x, which is this sort of quotation marks missing x from here. So all these things sort of play very well together. So we can construct these very complex pipelines of doing a bunch of functions after each other. So yeah, that's compose for you. I hope that that kind of makes sense. And I mean, this is really at the heart of functional programming, right? Like there's a lot of people who are saying that sort of category theory is about how things compose, right? Like category theory, the sort of mathematical concepts that underpin functional programming. So category theory is somehow about how different things compose, and within the context of functional programming, like how different functions from different domains compose, and how we can reason about how they compose. So this is when we get into stuff like, for example, associativity, like as I compose these functions, are these functions associative or not, for example. But yeah, now I'm treading on dangerous territory because I'm not at all an expert here, so let's quit this before we stray off too far. But before we move on, let's look at the function definition. Actually, sorry, there was one thing I forgot to mention, and that was, of course, that this point that they say that the rightmost function may have any arity, or in a pipe, the leftmost function may have any arity. So remember, arity is the number of arguments that a function accepts, and what they're saying is that, of course, the functions within this pipeline, right? So inc and double here, they all need to accept a single argument, because the return type, or because the return value of inc will serve as the input value to double, and the return value of double will serve as the input value to the third function here, the second doubling. So clearly then, because we can only have a single return value, there has to be only a single input value to the next function, right? We call function number 1, it produces some result, we pass it to function number 2. That produces some result, we pass it to function number 3. That produces some result, we pass it to function number 4, and so forth and so forth and so forth. But then our functions, of course, need to have an arity of 1. They need to be defined such that they only take a single argument, or at least that they can be usefully invoked with a single argument. I mean, they can have a higher arity for sure, and they can, for example, be curried, so we're partially applying them in this sort of pipeline. And this is very interesting and highly useful. But when we do the piping or the composing, we need to be aware that we are simply applying the function to a single argument. Or we assume that they have an arity of 1. Every function except the first, quotation marks, the either leftmost or rightmost function, depending on whether you do compose or whether you do pipe. And what they mean is then that, let's actually use this here. So instead of starting with instead of starting with inc as an increment, let's start with add, and let's define that as just r.add, right? So r.add takes 2 arguments. It takes an x and a y, and it adds the x and the y. So now we're starting with a function that takes 2 arguments. So then if we start with add here, actually, sorry, now before we didn't start with it because we hadn't put it in the pipeline, but if we put it in the pipeline here, I mean, actually, if we run it like this, it would probably blow up. Like, let's try that and see. Now we get nan, so it doesn't blow up, but let's just think about what happens. I mean, we'll do this in a useful way in just a moment, but let's just think about this, because now we actually do what I said before about partially applying the function. So if we only pass 10, and add takes 2 arguments in order to produce a value rather than a function. So if you think about it, I mean, actually, let's do that. If we console log, so if we console log r.add of 10, then we get a function, right? Because we get a function that expects the second argument. So if we then say 20, now we're actually applying it so that we get a value back. But before, when we only pass the first argument, we get a function back. So if you think about the pipeline here, what happens is that we pipe and we start with add. So if we only run 1 argument through add, we get a function, and then we pass that function as input to the function inc, which doesn't make any sense because inc is a function that adds 1 to whatever we pass it. But if we say console log, let's look at this. If we say inc of, let's think about it, add of 10, right? Notice that this is not r.add, it's add. Oh, actually, it doesn't matter. We can just say r.add. That's easier to think about, right? If we try to increment r.add, we get, oh, sorry, I missed the parenthesis. We get not a number, right? Because r.add is a function. We can't increment a function. So in our particular scenario here, this wasn't necessarily useful, but it's not that it's generally wrong. I mean, actually, it's sometimes useful to partially apply stuff within a pipeline or within a compose. But anyways, what I actually wanted to show, let's remove those lines, right? What I actually wanted to show is that if you start with add here, and we don't actually have to define add, actually, if I think about it, I mean, of course, we should just say r.add in that case, right? If we start with r.add, which is a function that takes 2 parameters, or 2 arguments, then we can start by adding 2 arguments, right? So f applied to 10 and 20, and if we run that, now we get 124. Why? Because the first function is add, it's plus, and it's the adding, the addition of 10 and 20. That's the first function, right? Or if we express it in prefix notation, I mean, it's plus applied to 10 and 20. Right? Which is, I mean, arithmetically I have to express it as 10 plus 20. That's the result of the first function. And this is the variadic portion, right? As they're saying here, the rightmost function may have any arity, but now we're using pipe, so it's the leftmost function. And then we're passing that through the normal piping, right? Where the next function is plus 1, and then the next function is times 2, and then the next function is times 2, because double and then double. Okay, and of course, I mean, if we say, so if this is f, then let's define another one which is g, and maybe this, and here we use compose instead, then this would be problematic. I think we'd get not a number here if we try to do this. Okay, we get a function actually, because add returns a function, and now that's the last thing we're doing. So if we're doing compose, we probably need to do this in the other order. We say double, inc, and then r.add, and now we can run that and we get the same thing, right? As you can see, I mean, we get 124 and 124, both when we do f and when we do g. And essentially, I mean, that was kind of expected, because pipe and compose are sort of the opposites of each other, or they do the same thing in different orders, left to right to left, and here we just flip the order of the arguments. But that just goes to show that, as they say here in the documentation, the rightmost function may have any arity in compose, but in pipe, the leftmost function may have any arity. And actually, of course, here they also say, see also pipe. So if we go to pipe here, we can probably see, yeah, they say the leftmost function may have any arity. But here at compose, the rightmost function may have any arity. And again, the remaining functions must be unary. In other words, taking 1 argument. But yeah, that's it for compose. Ah, sorry, of course. We were about to read the type definition, so let's actually read the type definition. So this looks a bit hairy. Actually, let me copy this in here so I can think about the parentheses. So paste that in here. Okay, so I'm just a bit concerned about whether, yeah, so this is the way the parentheses are balancing, right? Do you see how, so this is the first thing, and now it becomes obvious that compose is a function that takes some number of arguments, right? This first parenthesis, and produces another function, right? So we have to understand this as 2 portions. And this is not curried, right? So the second thing, so nothing in the second thing here is an argument. It's actually the return type. So maybe we should even do it this way in order to be super clear, right? And what are we saying then? So from the beginning, we're saying y to z, x to y, o to p, and then a function here, okay? And actually, if you just think about that, if we trivially replace these, so if I take the first parenthesis here and I replace that with f, and then we take the second parenthesis and we replace that with g, and then there's a dot dot dot. We take the third one and we replace that with h, and then what's up with this one? Yeah, this is also a full parenthesis and it's a function, right? So we'll replace that with I. And now it's starting to look a bit more clear, right? So let's say that you have f, you have g, and so forth and so forth and so forth, right? They're saying variadic. They're saying this first function, or the number of arguments that you pass to compose, can be any number of, right? You can have any number of them. It's variadic. So it's f followed by g followed by h followed by I. And if you do that, you'll get back a function that takes a number of arguments. It's variadic, a, b, n, and it returns some kind of z. Okay, so now it's a bit more clear what the structure is. But now let's undo backwards and let's go back to this structure. But why are we doing this complex stuff? What are these things? Well, the first one here is a function from y to z. The second argument is a function from x to y. and then we say dot, 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 and then they say, okay, well, and then it continues, so you can have another function which is O to P. But then, and if you think about it, these all look the same sort of in structure. It's from some type to another type, from some type to another type, from some type to another type. But then the final one is a bit different because that's the variadic function. Then they're saying, well, in Compose, rightmost function may have any arity. Okay, and that's what they're saying here. The rightmost function can have any arity. So you can have A followed by B followed by up to N, and that gives you an O. And then if we think about Compose as right to left composition, then we have to read these functions backwards. So then we're saying, okay, what if we first have a variadic function that when given something of A, B, up to N, it will produce something of O. Well, then that result can be piped into the next function, which takes an O and produces a P. But if that produces a P, then we can take that and pipe it into the next function within this dot, 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 dot. And assuming that that next function within this dot, 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 dot produces an X, then we can take that and pipe it into this function, or sorry, compose it into this function, which takes an X and produces a Y. And if that's a Y, then we can take that Y and put it into this function and put it through this function or apply this function, where when given a Y, we get a Z. And that's how we get a final Z value back in the end. But of course, when doing Compose, we get back a function, a variadic function, right? We get like a variadic function such that when we pass it the arguments that it requires, we get back something of type Z. Probably it's easier if we go to pipe here, right? If we copy that definition, let me put that on another line here. This is probably easier to think about. Let me actually, here I should break, right? So let's do the same thing with this. We put that on a new line. So that's the function that we produce. It seems we have, yeah, there seems to be a parenthesis missing here unless I'm mistaken, because the parentheses seem to not line up. Actually, maybe I accidentally deleted it. Let me just copy this again. Let's do that. Yeah, sorry, so I accidentally deleted it. My bad, but anyways, so that's that function, right? And this is probably easier to think about. Let's say this is pipe and this is compose. So here, the first function can be variadic. So then we're saying, given a function that takes something of type A, B, up to N, if it produces an O, then we can invoke that function. Then if we are given all of these arguments and we get an O, then we can pass that O to the next function, which takes an O and produces a P. And then we can take that P and pass to the next function, but here's this dot, 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 and this is why the letters don't match up. This is why we don't have a function which matches P, because here we're assuming dot, 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 that there's something that, or that the next function in this dot, dot, dot matches a P and produces something of another type, and so forth and so forth and so forth, until we have an X, and then we take that X and put it through this function, which when given an X produces a Y. And then we take this Y and pass it to the next function, which takes a Y and produces a Z. And notice this parenthesis, so this is one whole thing, right? That's what we invoke pipe with, and then we get back a new function, and this function is variadic because it takes any number of arguments, and the arguments that it takes matches the arguments of the first function that we pass to pipe. So it's A, comma B, and so forth and so forth and so forth, comma N. And then it produces a final N, right? Because what it does is that it pipes it through all of these functions, right? First through this one, producing an O, then through this one, producing a P, then through the next one, producing something else, and so forth and so forth and so forth, until we get an X, which we pass through this function, producing a Y, which we pass to the next function, which produces a Z, and that's our final value, right? Because the final type, or the final value, is of type Z, as expressed here. So this is very much the same definitions, like pipe and compose pretty much have the same definitions, just in different orders. So to me, this is one of these very interesting moments where it's like, well, I thought it was really tricky to read type definitions, and granted, I mean, clearly, if we go back to compose here, I mean, clearly they look super frightening, like super frightening. But actually, if you start to dig down, and if you just think about it for a moment, and you try to line up the parentheses, sometimes they are actually really, really simple. So hopefully you're seeing how this adds up. And if not, just think about it another lap and try to match up the letters, and I think you'll probably get why this is the way it is. So anyways, that's it for compose, and actually that's it for pipe as well. Let's remove all of this stuff, and let's move to the next one.